So you're watching this video because you want the solutions and explanations for the upcoming probability test. So let's work through it. Remember, you can pause it at any time and go back and go over it. So I'll go through fairly quickly. Sample space in question 1 is all the possibilities that can occur on a standard die. They're the numbers 1 through to 6. For question 2, when a die is rolled, the probability that it will land showing a 4. Well, there's 1 4 out of the 6 possibilities, so we write 1 and 6. The probability that it will land showing a 5 or a 6, there's 1 5 and 1 6. So there's 2 possibilities out of the 6 in the sample space, so 2 out of 6. But remember, we must always simplify our fractions, so that comes down to 1 on 3. For part C, the probability that the die will land showing a 7, well, there's no 7s out of the 6 possible outcomes on a die, so that's an impossible event, so the probability is 0. For a prime number on a die, remember a prime number has only 2 factors, and out of the sample space on a die, those numbers are the numbers 2, 3 and 5, so there's 3 numbers out of the 6 possibilities, which simplifies down to a half. That leads us to question 3, the sample space we want for a coin being tossed and a die rolled. So that an easy way to do that is now table. And it could land on heads or tails for the coin. The die could land on the numbers 1 through to 6. So if it landed on heads for the coin, then we can have the numbers 1 through to 6 for the die. And tail for the coin, the numbers 1 through to 6 for the die also. So there's 2 lots of 6, which is 12 possibilities there. So in red there is our sample space. So if a coin is tossed and a die is rolled, the probability that the coin shows a head and the die are 4, well, heads and 4, there's only 1 out of the 12 possibilities. For the second part, the probability that the coin shows a tail and the die an even number, well, if we look in the table, tails and an even number, there's tails 2, tails 4 and tails 6, so there's 3 out of the 12 possibilities, which simplifies down to a quarter. And the third part, probability of a tail and a number less than 4. Just remember 4 is not less than 4, so we want a tail 1, tail 2 or tail 3, so there's 3 possibilities out of the 12, which again simplifies to 1/4. In question 4, we want to shade the Venn diagram. So we don't want not A nor B, so we want all of those elements that are in neither A and neither B. So we don't want A or B, so we want all the ones that are outside of those, which is shaded in red there. For part B, we only want B only, so we don't want any of A, and we don't want any that are in neither. So what's shaded is those bits that are only in B, no common part in A, so make sure it's only B. With question 5, A and B are mutually exclusive, so what does this mean? It means they have no parts in common. So there's nothing in A that's also in B. So if we were to represent that on a Venn diagram, there's A, there's B, they have nothing in common there, so there's no overlap. In question 6, we have our Venn diagram here. There are 13 in A only. There are 7 that are in A and B, so altogether we've got 20 in A. There are 10 that are in B, 7 that are in A and B, so altogether we've got 17 in B, and there's 5 in neither. So if we put that information into a two-way table, we want all the elements in A in this column. So if we go here, we want the ones that are in A and also B, which is this common part here. So there's 7 of those. If we want the ones that are in A but not B, remember that means not B. So the ones that are in A and not B, there's 13 of those. So altogether we have 20 that are in A. If we want the ones that are in B but not in A, right, there's 10 that are in B and not in A, so there's 10 of those. So altogether in B, there are 7 and 10, 17 altogether. Those that are not in A and not in B, are these 5 here. So those that are not in A and 10 and 5 is 15. I've got one missing here, so we put that in there. That's 18 that's missing from there. So a check is 17 plus 18 gives us a total of 35 elements. And we can check across this way, 20 plus 15 is also 35. So to do part B, we can either use this two-way table or the Venn diagram. The probability of those in B, there's our B, altogether in B is 17 out of the 35. So we write that as a fraction and simplify if we can, which in this case doesn't. The second part, probability of A and B. So there's A and B, so there's 7 out of the 35 possibilities, and that does simplify to 1 on 5. And if we scroll down, we have a look at the probability of A given B. Well, remember B has happened, so there's 17 in B, and those that are also in A, there's 7 out of those 17. So those that are in B, there's 17 in B altogether. Those that are in A as well as B, so this is also in B as well, there's only 7 that are common in those. Question 7. There are 18 birds altogether, so that means if we add all of these up and any out here, there should be 18 altogether. 13 birds have tags, there's our tags group here, so there's 13 in there. 9 have clipped wings, so there should be 9 in here, and 4 in both. So we do that part first, put our 4 in both, remembering there should be 9 that are clipped altogether, so 4 plus 5 gives us our 9. And there should be 13 with tags altogether, so 4 plus 9 gives us our 13. There's none that have neither, so we can add those up. 5 plus 4 is 9, plus 9, 18, which is how many we need. This leads us to question 8. We have to do a bit more thinking ourselves. There's 3 babies born. We want to draw a tree diagram. There's our hint, tree diagram, to come up with the sample space. So our first baby could either be a boy or a girl. So these branches here and here represent our first baby, either a boy or a girl. Now regardless of that first baby, our second baby, which are these branches here, could be a boy or girl, remembering it could have been a boy first and then a boy or girl, or it could have been a girl first and then a boy or girl. So these middle branches represent our second baby, and then regardless of the first 2, we could have our third baby. That's our tree diagram. However, it is not our sample space. To answer our sample space or come up with our sample space, we read along the branches. So boy, boy, boy. That's why we have 3 B's there to begin our sample space. Boy, boy, girl comes up with our second in our sample space. If we keep doing that, girl, boy, girl, we get this part in our sample space, this element here, and we have a look. They're already done for us now. There are 8 possibilities there. This is our sample space. Make sure we include it because that's what the question asks for. That now takes us to question 9, where we've got Jake hitting a target 65%. That means he has a 35% chance of missing. And Tori, she hasn't been practicing so much, so her chance of hitting the target is 47%, which means she has a 53% chance of missing. So if Jake goes first, hitting it is 65%, we need to put that in, and missing it is 35% there. Then if Tori has her shot, she can hit it, which is 47%, or miss 53%. Remembering that if Jake hits it first, or he could miss it first, so we need these extra branches along here to make sure we finish that probability tree. We could now use that probability tree to help us to answer these questions. The probability that they both miss, so Jake missing first is 35%, Tori missing second is 53%, so miss, miss, multiply them together, and we end up with 0.1855, or if we change that back to a percentage, times it by 100 and get 18.55%. Or your calculator may have even shown this as a possibility as a fraction. Either of those three answers are acceptable. The second part, if only Tori hits the target, which means Jake has missed, and then Tori hits, so multiply along the miss hit, so 35% times 47%, and again we have our three possible answers that are acceptable there. So this leads us to our next question, where question 10, Fiona has a bag that contains 14 red lollies, 10 green lollies and 16 blue lollies. So that means 14 plus 10 plus 16 is 40 lollies altogether. If one's chosen and only one is chosen, what's the probability that it's green? Well, there are 10 green lollies out of the 40 possibilities, so we get 10 over 40, which simplifies to 1 on 4. Part B, if one lolly is chosen and replaced, meaning it's put back in before the next one's done, find the probability that both are red, so probability of a red. Now you'll notice here in my solution, I haven't completed the whole thing because I haven't really needed to. I want probability of red and red, so first of all we could choose a red, green or blue lolly out of the container, where 14 out of the 40 are red. I haven't needed the green or the blue because I'm choosing a red first. Then from each of those, regardless of what my first lolly was, I could then still choose a red, green or blue, remembering the first lolly is put back, so there's still 40 of them, and 14 of those 40 are still red. So the probability of red, if I multiply along the branches, 14 over 40 times 14 over 40, and simplify that, and it comes to 49 on 400, and your calculator does that for you. Remembering, I didn't have to complete all these other branches and so on because I only wanted red. Part C, is the event described in Part B above dependent or independent? Did the second lolly being chosen, was it affected by the first one being chosen? Well, no, because the first lolly was put back in, so there was still 40 in there, so this is what we call an independent event. And we had to circle our answer. Well, we used an ellipse instead, not quite a circle. And Part D, the last part of the revision sheet here, the first lolly is chosen is eaten before the second lolly is chosen, which means there's now only 39 left before the second one is chosen. So, what's the probability that the first was blue and the second was green? So we want the probability of a blue then a green. So we can start off our probability of tree again, red, green, blue in our three possibilities. And I'm choosing a blue first, so I've got 16 on 40 there. I haven't completed all the other parts up there because I don't really need them. I only want the blue first, and then I want the green. So there are still 10 green ones left, but now there's only 39 lollies left in the container. So make sure that we've got 10 over 39, and the probability of blue, green, multiply it along the branches there. Right, 16 on 40 times 10 on 39. Put it in your calculator, and your calculator will simplify all of that for you to 4 over 39. So hopefully that has given you some more insight into how to do the revision sheet and how to do a lot of the probability that we've covered throughout this topic. So good luck in your upcoming test.